All right, let's get started with section 12.6, surface area and volumes of spheres. All right, our objectives are to find surface areas of spheres and also find the volume of spheres. And our essential question, how can you find the surface area and volume of a sphere? Let's start with some key vocabulary. To find surface area of spheres, let's get to know the parts of a sphere. First of all, a sphere is the set of all points in space equidistant from a given point, known as the center. So here's an illustration of a sphere. So we know that the center of the sphere is right there in the middle of the entire sphere, and then the radius is any length segment from the center to a point on the sphere. And there are infinitely many radii. It's not just right here, but this is an example of one radii of this given sphere. Then our chords of spheres. So we've seen this word chord before. It's the segment whose endpoints are on the sphere. So here's an example of a chord, but you can have infinitely many chords going all around the sphere, as long as the two endpoints are on the sphere. And then the diameter is a chord that contains the center. So it has to pass through the center, and then its endpoints have to be on the sphere. Again, you can have multiple diameters, infinitely many diameters, not just this one. All right, here are some additional details about our spheres. As with circles, the terms radius and diameter also represent distances. Super important. It's all about distance or length. And the diameter is always twice the radius. Well, that's true for a sphere as well. If a plane intersects a sphere, then the intersection is either a single point or a circle. And the either is based on what type of intersection or what type of plane passes through your sphere. If the plane contains the center of the sphere, then the intersection is a great circle of the sphere. And then the circumference of a great circle is the circumference of the sphere. Every great circle separates the sphere into two congruent halves, and these are called hemispheres. All right, so one of the formulas that we'll be working with is our core concept for surface area of a sphere. Again, capital S, and then our formula is 4 times pi times the radius squared. Remember, r is your radius, and it could be any distance from center to the outside of the sphere. All right, let's get familiar with this new formula, 4 pi r squared. Here we have example A, sphere, radius is 8. So let's start by getting the formula in our workspace. So our formula is 4 pi radius squared. We also know that our given information, radius, is 8. So we're going to substitute 8 in for r. So that means 4 times pi times 8 squared. So do order of operations, multiply your numbers first, leave pi alone, don't put it in your calculations yet, because we want to practice exact. Surface area first, which is going to be 256 pi and then inches squared. Now, 256 should be in your calculator, so all you have to do now is hit the multiply key and then your pi key and hit enter to reveal an approximate value of 804.248 inches squared. Remember, I want you practicing exact and approximate values anytime you're dealing with pi. All right, for example B, we're given the circumference of our sphere to be 12 pi feet, but we're still asked for the surface area. So let's start with that main formula first. And since we start with the circumference and we're being asked what is the radius, the length of the radius. So that means I have to do a sidebar calculation involving circumference. So we know circumference of a sphere is the same as the circumference of a circle, so C equals 2 pi r. We're told that the circumference is 12 pi. So we substitute 12 pi for capital C, so we get 12 pi equals 2 pi r. Next, we would divide 2 pi on both sides, resulting in a radius value of 6. Now that we know that our radius is 6, we can substitute 6 in for r into our master formula for surface area. Again, practice getting exact So multiply your numbers. So you get 6 squared, 36. 36 times 4 is 144. Leave pi in your answer. So 144 pi feet squared is exact surface area. Then in the calculator, you can calculate with the key, pi key, the approximate value of 452.389. Don't forget your units. Feet squared. Surface area is always always squared. All right, example 2, find the diameter of the sphere. So here we know that the surface area is 20.25 pi. Again, start with your master formula in your workspace. So surface area equals 4 pi r squared. And then a sidebar note of list of all your parts. So we know the surface area is 20.25 pi, which in other words is exact. So here's a prime example where knowing and recognizing exact values is important. And we are using exact surface area to plug into our formula equal to 4 pi r squared. So what we need to do is solve for our radius, our r value. So next we would divide both sides by 4 pi, resulting in 5.0625 equal to r squared. Now to undo squareds, we have to square root. So our radius comes out to be 2.25, the positive value after you square root. We cannot keep the negative value. It doesn't make sense to have a negative length of radius. So we now need to double that radius because ultimately we're being asked about the diameter of the sphere, not the radius. So we need to double that radius because that's the property of a diameter. Double the radius, twice the radius, so we get 4.5 centimeters for our diameter. All right, our next formula, core concept, is the volume of a sphere. And the volume is 4/3 times pi r cubed. Again, r is the radius of a sphere. All right, so we're going to find the volume of this soccer ball. Let's start with our main formula. Our main formula is 4/3 times pi times the radius cubed. And we are given that the radius is 4.5. So we substitute 4.5 in place of r, and we need that value cubed. So here we will just multiply our numbers. So get 4.5 to the third power. You want to do order of operations. Leave pi out of your calculator. Don't put pi in the calculator yet. Just do 4.5 cubed. Now multiply that by 4/3, and you should get 121.5. Again, leave pi alone, stays in the answer. So this would be an exact volume of the soccer ball. Now hit multiply to pi, and this is the approximate volume. Should have gotten 381.704 inches cubed. Now as you take your notes and practice these problems, it's very important that you try to type all of this information in your calculator, because here's where you have an opportunity to make sure you're typing all of this information into your calculator correctly. Because then if you're not typing it in correctly, this is where you would be able to identify maybe how you're typing it in the calculator incorrectly, and or also just practicing using pi and various other keys that are necessary for calculations. All right, next let's see what happens when we change dimensions. What's the effect on the volume of a sphere? So let's describe how multiplying the radius by 1/4 affects the volume of the sphere. So as usual, we look at the before change. So we know that before we change the dimensions, our radius is 12 inches. We plug in that 12 into our volume formula. Again, leave it exact so we can compare to the exact on the after change, and we get a result of a volume 2,304 pi inches cubed. This is before we do any changes on radius. All right, so now we're going to change our radius by multiplying 1/4 times 12, getting a result of 3 inches. So we're going to plug in that 3 value into our master formula, so 4/3 pi r cubed. Substitute 3 for your radius, and that gets us 3 cubed times 4/3, again leave it exact, resulting in 36 pi inches cubed. So we can already tell it definitely got smaller. So what is the effect? Well, divide that new volume by the original volume, And that's how you compare. Should have gotten 1/64 when you divide those two volumes. And 1/64, I want us to rewrite that as a factor cubed. So 1/4 is our factor cubed. It's equivalent to 1/64. And when I like to see this, when I like to convert it to this version of our value, is so that you can see this 1/4 matches the original scale factor, except it's being cubed. So multiplying the radius by 1/4, so a single dimension changed by 1/4, changes the overall original volume by that same factor cubed. All right, and our last example we want to look at is a composite solid. So our composites here are a cylinder and a hemisphere. And it looks like the hemisphere is dug out of the cylinder, which means I'm going to subtract. So I know that to get the volume of the entire composite solid, I need to take the volume of the cylinder and subtract the volume of the hemisphere. So after you state in words the master formula for the composite solid, replace the words with our formulas from the formula chart. So we know to get the master volume, the volume of the composite, that's going to be capital V. To get volume of any cylinder, it's pi r squared little h. In other words, big B little h. So big B got replaced with pi r squared. We already know this from previous work. And then a hemisphere is half of a sphere, which is where this 1/2 comes from. And then a full sphere's volume is 4/3 pi r cubed. So we're taking half of a full sphere. So in order to know what values to substitute, it's helpful to know the parts of your solids. So let's take a look at the parts of a cylinder. We know that the radius is 2 inches, and we know that the height of the cylinder is 2 inches. So we're going to plug those numbers in the appropriate places. And then we know the parts of the hemisphere are that the radius is 2 inches. So for the first part of our formula, the r will get replaced with 2, as we stated earlier for our cylinder. The height of the cylinder was 2. That was noted in our workspace. The radius of the hemisphere was 2, as also noted. They happen to all be 2's. So we'll work these out in order. So you have 2 squared, which is 4. 4 times 2 is 8, which is where this 8 came from. So you have 8 pi for the volume of the cylinder. Work out separately the volume of the hemisphere. So 2 cubed is 8. And then 8 times 2/3 is 16/3. Again, leave pi in your answer. And then 8 minus 16/3 combines to be 8/3. Again, leave pi in your answer to be exact. So our exact volume of this composite is 8/3 pi inches cubed. Then you can type this in the calculator, and the approximate volume is 8.378 inches cubed. All right, and that's all for our volume and surface area of spheres. See you in class.